Hi, my name is Scott with Garner, Holt Education Through Imagination, and today I'm going to be giving you a quick lesson on how to configure and program your animatronic figure using the Education Through Imagination Electronics Kit. Today I'll be using this 6-function animatronic Songbird, but this lesson will apply just the same to the Songbird Mini or any other figure that you're using this system with. I'll be giving you a few warnings and best practices as we go through, so be sure to watch the entire video first before following along with your project. Let's get started. To get started, we'll need your main control board, slider board, Ethernet cable, speakers, servo tester with power cable, SD card adapter, and power supply. We're also going to need a computer to edit our configuration file, preferably a PC, but a Mac will work too. Before we get into connecting anything, I want to talk about some of the safety considerations with this system. Firstly, all safety considerations that you know from other electronic devices are in place here, including, but not limited to, not pulling things from the cord, pulling from the plug itself, not getting water anywhere near this system, and so on. This board is low voltage, so we're more likely to hurt the components than hurt ourselves, but keep these safety considerations in mind. Static electricity can be extremely dangerous to our components. That's why this board comes in this pink anti-static bag. Keep the board in the bag until you're ready to set it up, and place the board on top of the bag during setup. Also, avoid handing electronics from person to person, as the difference in static electricity between you can arc and damage components on the board. Always make sure to check polarity, that is, plugging in positive to positive and negative to negative, as reversing these can cause damage to components. But don't worry, follow along, and I'll help you get everything connected correctly. Another note for later, when we get to plugging in servos, is to never try and move servos by hand when they're powered up. I'll talk more about this later. And lastly, some of the pins on this board can be sharp, so be careful when handling. Now let's get everything connected. You should have your servo extenders installed and cable managed by this point, but a quick recap. Here on our servo extender, there are 3 colored wires, white for signal, red for positive voltage, and black for ground or negative. Some servos may have different color codes, but they follow a similar pattern. Just know which one is ground and you'll have no trouble. Like on this one, the black is ground, just like the black on this extender. Attach your extenders inside the body of the bird, that way you can do maintenance later. If you cover up the connections with clay on the perch, you won't be able to work on servos without tearing apart your figure finishing. We'll leave the servos to the side for now and work on connecting the other components to our main board. First, connect one end of your Ethernet to the main board, and the other side to the slider board, making sure that they are oriented correctly and seated all the way in. Your speakers have 2 connections. Plug the headphone plug to the matching audio jack on the main board, and the USB, which is for speaker power, to the USB port. Don't connect your power supply just yet. Now we can move on to setting the parameters of our servos. Before we get to finding our servo parameters, I want to talk a little bit about what that means. Most servos, like this one here in the head of our bird, have the ability to rotate 180 degrees. But as you can see with this beak function, we only need our servo to move about 10 to 15 degrees to get that full motion of our function. We need a way to tell our servos that this range is all they're allowed to move in, because moving past that range can damage the figure or the servo itself. So what we need to find are the endpoint in degrees of this range. These numbers are referred to as our servo parameters. To find these, we're going to use our servo tester. This device will move our servos and display in degrees the command that the servo is getting. So what we're going to do is connect a servo, move it with this slider to its physical limits, and record the number we see on the display. Let's make sure our servo tester is working. First, we're going to make sure that the tester is connected to power. And we can see that it's on from the number on the display. Also make sure that this jumper up at the top is connecting the middle and the VUSB pins. Next, we'll take one of our servos. This one is normally for the body lift function of this bird, and plug it into the servo out pins next to the blue terminal block. We need to make sure again that we're plugging this in the right way. You can see on the board beneath those pins an S, plus, and minus. So we're going to make sure the black on this servo is going to the minus or negative. And before I plug in a servo, I'll normally put the slider somewhere near the middle and be ready to move it as soon as the servo gets plugged in, just in case it's moving past a physical limit. So let's test this. I'll make sure that black is going to negative, plug this in, and move the slider. And you can see that my servo moves, and I get a degree output on the display. Remember from this point on, if there is ever an unusual condition, like a servo making a really loud grinding noise or some erratic behavior, disconnect power immediately. Failing to do this can result in damage to your components. So now let's try this with our actual body lift function. I've got the servo extender for that servo, and I'm going to make sure that the black is going to the negative on my servo tester and plug that in. You can see the servo and the function immediately move to the position of the slider, and so we're going to find our endpoints now. What I'm going to do is gently move the slider till I reach one of those endpoints. And the way I determine an endpoint is when the function hits something or I can hear the servo working too hard. So let's gently move this. You see we move it up. And we can see at that point that the servo horn is hitting, and that's the end of the function. So I'll determine what that is by looking at the numbers on my servo tester. In this case, it looks like 23 degrees. And I'll write that down for my body lift. 23. Now let's move it in the other direction to find the other endpoint. We can see that the function stops moving here, and we can hear the servo working a little too hard. So I'll back up a little bit, and that's my second endpoint. In this case, it looks like 103 degrees. Don't be alarmed if you see it flickering between a couple of degrees, just pick one. So now I know the limits for my body lift servo are 23 to 103 degrees. And once I put that in my configuration file, that servo will no longer move past those endpoints. Let's see that process again, but this time with the head turn function. I find the servo extender for the head turn, making sure once again that my black wire goes to the negative on the servo outside. You see the servo immediately get to that position, and once again we're going to slowly move to those endpoints. In this case, you can see once my slider gets to about right here, the function stops moving, and if I go past that, the function isn't moving anymore, meaning the servo is at an endpoint and working too hard. So we want to go just before that. In this case, it looks like at about 70 degrees. So let's write that down. Let's head the other direction. And it looks like we almost make it to our maximum, but just before. So let's write down 152 degrees. Repeat this process for all of your servos, remembering to make sure that the servo isn't making any grinding noises at either of its endpoints. Also, it's a good idea to back off a few degrees just to keep that servo healthy. Your audience won't notice a few degrees of movement missing, and your servos will last much longer. Notice I haven't recorded which number was up or down. You'll find that this really isn't necessary, and we have a way to flip our channel around later if this isn't correct. And a few last notes about these parameters. This endpoint number is dependent on which orientation you've installed your servo horn in, meaning no two figures will have the exact same parameters, and if you remove your servo horn and reinstall it for whatever reason, this process will need to be repeated as those endpoints in relation to that servo have changed. Also, while I'm showing you this process with no figure finishing on this bird, remember that adding things like fur and body shells can possibly make this range smaller by adding physical limitation to your servo's movement. So the best practice is to do this when everything has been installed on your figure. Lastly, it's a good idea to label your servo extenders with the name of the function that they go to. This will make hooking everything up much easier later on. Now that we have all of our servo parameters, let's write them to our board. Now we're going to update the configuration file on our control board to impose these limits on our servos, as well as configure some other options. To do this, we'll need our control board, our micro SD card adapter, and a computer. First, we're going to remove our configuration micro SD from our control board. Notice that there are two micro SD cards on our board. One is for configuration, and the other is for audio. We want this one on the main board right now. This can be difficult when it's brand new, but be gentle to avoid any damage to the card or port. Also, never remove this card when the power supply is plugged into your board. This can corrupt the files or make your micro SD card unusable. We'll carefully plug this card into our adapter with the word side of the card matching the word side of our adapter. And we'll plug this into our computer's USB port. Looking in my File Explorer, I see this drive named Attacore, and we'll open that up and see a couple of things. There's a folder with some example files that we won't be using, and then two text files, config and track1. Config is the file we'll be editing. We will not touch the track1 file. It holds information for our animation that we've recorded, and tampering with it can cause unwanted behavior. A note about this config file. Our board will be reading this line by line, expecting everything in place where we see it now. When editing, make sure not to add symbols, add or remove lines, or change the format in any way. Doing so can cause the board to behave strangely or not function at all. To protect ourselves against any of these mistakes we might make, I'm going to make a copy of this config file and save it to my desktop. Let's open up this config file and take a look at everything. Here in our config file, there are two different types of lines. Some start with this hashtag symbol, and others start with asterisks. The ones with hashtags are comments that are not read by the board and are just for our organization. There's several parameters throughout this config file. I'll go through them one at a time to tell you which ones you should be concerned with. This first line is record protect. This helps us from accidentally deleting a show that we've recorded. You can see we have it set to no right now so that our record button is enabled, but changing it to a P will disable our record button and save our show. We can ignore this line about radio frequency as we are using the wired system. This block is for our servo parameters. This is where we'll be spending most of our time a little bit later. We can ignore this block about digital output polarity as it's for an advanced feature. These next three settings, trigger enable, trigger power up delay, and trigger delay lockout, are another advanced feature that we won't be covering at the moment. These next two settings, replay enable and replay delay, are for looping our show once it finishes. When enabled, after waiting the specified delay time, our show will play again. This next setting, audio board enable, will always be enabled because we always want to have sound on our animatronic figure. And the next two are for clip 1 and 2 volume. We'll keep both of those at max, which is 30. This next setting, jaw enable, is for an automatic jaw function that I'll talk about later. After that, we have two settings, play and loop audio clip 1 and play audio clip 2. Both of these will always be enabled. And finally, these last two settings are for fine-tuning that automatic jaw feature, again that I'll explain later. Now let's work on that servo parameters block. We can see here on the left that there are servo numbers 1 through 8. So what number should we put our servos on? Let's talk about that. You'll see on our control board next to this row of header pins, there are these tiny markings that read S1 through S8. These correspond to the servo numbers 1 through 8 in our config file and a certain control on the slider board. As you can see, we have sliders 1 through 8 from left to right that these numbers correlate to. But we also have these two joysticks. The left joystick is connected to servos 1 and 2. And we can use this toggle switch on the bottom board to switch between controlling channel 1 and 2 with the joystick or with sliders 1 and 2. Note that when the joystick is enabled, the first two sliders don't work, and when the sliders are enabled, the joystick will not be active. This same concept is true on the other side of the slider board for channels 7 and 8. Now that we know this, we can assign which control we'd like for each servo. You can pick whatever control scheme you like. Personally, I like putting my head turn on 1 and head nod on 2, as these functions work together well on the joystick and makes programming easier. But you can experiment with whatever you like. Once you have what channel you'd like for each servo, input the endpoints in these first two columns, keeping the 3-digit format. I have my body lift channel on servo number 4, so I'll make that 23 to 103. I have my head turn on channel 1, which I have the endpoints 70 to 152. Notice that I keep the 3-digit format even if I have a 2-digit number. Let's put in the rest of these. There we go. All my parameters are set into this block. You can ignore the second two columns, but remember not to delete anything or change the format. Do this for all of your servos and click File, Save. While we're in the config file, I want to talk about one more fun feature that I mentioned earlier, and that's the automatic jaw function. Your board comes preloaded with a function that allows one servo to be controlled automatically by reacting to your sound file. I'll warn you up front that this feature is great for simple audios like birds chirping or basic dialogue, but since it operates by reacting to sound level, more advanced audio tracks and dialogue might not look the way you expect them to. I'll also show you how to have this feature ready at any time when we need it. In our config file, we have this entry to enable automatic jaw for servo number 6. Your file still may have this typo in the comment that says S8, but for this version of the board, it is indeed servo number 6 that has the automatic jaw. Since this is just a comment line, I can change that 8 to a 6, no problem. With this enabled, we'll come up to the Servo Parameters block and input our values for our beak servo into number 6. Here's my tip for this feature. When Servo 6 Auto Jaw is enabled, we cannot control the beak manually at all. It will only move with our audio track. But sometimes I might want to move it myself, and I don't want to have to come into the config file every time I want to switch that. So here's what I do. Since we have some extra servo channels available, remember this bird has 6 servos and our board can accommodate 8, I like to put my parameters for the beak into both servo 5 and 6, and leave automatic jaw enabled at all times. This way, if I ever want to switch, all I have to do is take my servo plug from the S6 slot and move it to S5. It's that easy. There are additional lines for adjusting this feature, like enabling these other frequency bands and using the potentiometer on the board itself to tune this feature. Once we like everything in our config file, we need to make sure to hit File, Save, and then we can exit out, and we must properly eject our drive. If we don't do this, it can corrupt the files on the card or make the card unusable altogether. So I'll come over to the drive, right-click, and click Eject. We get a message that this is safe to remove, and now we can pull the card out of our computer. After we eject our drive, we need to take out that micro SD card and place it back into our main control board. Now it's time to hook up the servos to our control board. But before we plug those into the servo rail, I want to mention something about this rail you see next to it. These little black pieces are called jumpers, and they let us select which power source we want to use for our servos. One uses the internal 5-volt regulator at 1 amp shared. The other uses the full power of the supply. Since we've provided you with a 6-volt supply, which is the perfect voltage for these servos, we can use that full power. So switch all of these to be connecting the VS and SVN pins together by gently removing them and placing them on the proper pins. Now we're ready for our servos. Notice on this servo rail there are color-coded bars that correlate to the servo pin assignment. In this case, it's yellow for signal, red for positive, and black for negative. Be sure to plug in your servos the right way to avoid any issues. Follow your plan for which servo goes into which port and plug each one in carefully. Remember, there will be some empty ones as we don't have all 8 servos. And for mine right now, I want to control the beak manually, so I'm going to place my beak into servo number 5. I'll start with my first servo, head turn, which I planned for number 1. So there we go, we have all 6 of our servos plugged in on the right number, making sure that they're all lined up the right way. Notice I have black for negative, all on the same side. There's one more thing we need to do before we power this up, and that's adding our sound files. Because we enabled the audio board in our config file, we need to have a file present on our audio SD card, or the board won't make it through its startup sequence. Remove the audio micro SD by pressing and releasing. The card should pop out, and you can now remove it. Using our adapter from earlier, we can plug this into our computer the same way we did for our config card. Depending on the version of your board, you may have some sample files on here. So let's talk about the 2 tracks that go into this board. You'll remember from our config file that there is reference to 2 audio tracks, our ambient and our main audio. Our first track is our ambient. This loops when our show is not playing. For my sample file, I have some ambient jungle sounds. Our second track is our main track for the show. This will play when we record or play back our show. This board only works with MP3 files, so if you're downloading or creating your own audio, make sure it's in this format. We'll copy our files to this card one at a time, starting with track 1, our ambient. And you'll see that I've named it 0001_ambient to keep track of it. Next, we'll copy our main audio and do the same, naming it 0002_main. You do need to copy these one at a time in this order, or the tracks may be switched when operating your figure. If this happens, simply delete the files off the card and recopy them in the correct order. Now we can eject our card and place it back into the audio board. Now that we've got that all done, we can plug in our power and check our work. So I've got my power supply plugged into the wall, and then I'm going to take the other end here and plug it into this barrel jack on the main board. And when I do that, the servos should come right on, and then relax, and we're ready to control it. A word of warning, our board is programmed to send each of these servos to the last recorded position on startup. So since we haven't recorded anything yet, you may see your figure contort in some weird ways and go outside of those endpoints that we set earlier, but just for a brief moment before relaxing. At this point, we should be able to move some of our servos with the sliders on our board. If we can't move them right away and the servos haven't relaxed, unplug your board and go to the troubleshooting section of this video. If everything powered up correctly, we should see a solid green light over the reset button on our slider board and on our main board. We should also see a solid light on the audio board telling us that our background audio is playing. Your speakers have a volume knob. Increase that volume here, and we should hear our background audio. Your figure is now in live mode, which means we should be able to move these joysticks and sliders and see our figure come to life. At this point, there's a couple things we want to check on, mainly that these servos are moving within the ranges that we set for them in that configuration file. Remember, we're testing on this bird without any figure finishing, so make sure all the figure finishing elements are installed on your bird prior to checking these. Also, you can check and make sure that all of the servos move the way that you expect them to on your slider and joysticks, and make note of any of them that need to be flipped. For example, notice when I turn this joystick to the left, the head moves to the right, and vice versa. That's an example of a channel we'd want to flip to make it easier for programming later. All I'm going to do is make a note of every channel that needs to be flipped, and then head back into my config file. which first I need to unplug to do. I'm going to once again remove my config micro SD card, put that into the adapter, and open it up in my computer. So in my configuration file, we're going to go to the Servo Parameters block, and we noticed that the head turn function was the wrong way around. In this case, that's number 1 for me, where I have 70 to 152. To reverse this, I'm simply going to swap these numbers. So it'll be 152 to 70. Now when I move my joystick to the left, the head will go to the left and vice versa. Remember to save, file, save, and properly eject the card. Now, if I flip that correctly, when I move my joystick left, my head moves left. When I move it right, the head moves right. This makes it much easier when I'm programming. Now that we've verified that everything is set up correctly, it's time to record a show. This is easy to get started, but may take several tries to master, so don't worry about getting it on your first try. To record our show, we will simply hit the record button, labeled REC on our slider board or our main control board. The light over the button will flash 3 times. This is telling us to get ready. Then the record light will go solid, and the light on the audio board will turn off and back on again, letting you know that our main audio is playing. This means the recording has started. In this mode of recording, your board is recording the movements for all your functions at once. This can be tricky if you have more than a few servos. So use the automatic jaw feature or grab a friend to operate some of the functions for you. I'll give you a quick demo of what a live recording looks like. I've got my speakers turned up, and I'm going to press the record button on my remote. Wait for that to go solid. And now I'm recording. So everything I do on the sliders will be live output on my bird. And once I'm done recording, I'll press this record button again. It should turn off, and my bird will be back in live mode. Now to watch that sequence back, I'm going to press the button to the left of the record button, which is play, and it should go solid and play back all that motion that I just recorded. And simply press play again to stop and go back into live mode. You'll notice when I was recording that all the functions were active at once. There is a more advanced way to record, just a couple functions at a time, but we'll cover that in another video. Something else to be careful about when we are playing our show back is to not accidentally hit the record button. Pressing the record button will wipe out the show that you've recorded and start recording all over again. So be sure that you press the play button when you mean to, or set the protect function on in the configuration file. Congratulations! You just successfully recorded your first animatronic show. Hopefully everything is working smoothly, but if anything isn't behaving quite right, check out our next video all about troubleshooting some of those errors. And if you're interested in purchasing one of these kits that you've seen in this video, visit our website at garnerholteducation.com or email us at info@garnerholteducation.com.